What would you think if the day suddenly began to turn into night, even while the sun was still high in the sky? It might sound a bit scary, and for most of human history, it was. As the sun began to disappear, some imagined it as a sign of angry gods, others of celestial monsters consuming the sun. According to one legend, two great armies were once massing for battle when the sun began to disappear. They were so frightened that they laid down their weapons, and when the sun returned, they signed a peace treaty and went home. Today you can have a different reaction to a total solar eclipse. You can applaud when the sun disappears at the exact moment that scientists have predicted. You can look up in awe at the beautiful sight of the sun's corona, and you can marvel at the fact that events that terrified and mystified our ancestors are now so well understood that we can predict them thousands of years in advance. Hi, I'm astronomer and author Jeffrey Bennett, and I've created this video on behalf of Big Kid Science and Storytime from Space to help you understand how to experience a total solar eclipse for yourself. If you were lucky enough to be on the narrow path of totality for the Great American Eclipse of 2017, or of any other solar eclipse, then you already understand the magic of seeing a total solar eclipse. If not, you probably have friends who saw it, and who will encourage you to travel for an upcoming eclipse. You can use the Totality app to select the map for one of several upcoming eclipses, including the 2024 eclipse that will cross through Mexico and the United States. For whichever eclipse you choose, to witness totality, you must be located somewhere along the narrow shaded path, for which the center line is in blue. The much larger region around this path will experience a partial solar eclipse. To understand the difference, we need to talk briefly about how a solar eclipse occurs. A solar eclipse occurs when the moon passes directly between Earth and the sun, so that the moon's shadow falls on our planet. Notice that the moon's shadow consists of two regions. Within the full shadow, called the umbra, the moon completely blocks the sun, creating a total solar eclipse. Within the partial shadow, or penumbra, the moon only partially blocks the sun, creating a partial solar eclipse. The closer you are to the full shadow, the more of the sun that will be covered. Here we see the full shadow and the darker portions of the partial shadow moving across the face of the Earth, as seen from space by NASA's Deep Space Climate Observatory during a recent solar eclipse. The motion arises from a combination of Earth's rotation and the moon's orbital motion. In fact, the shadow moves quite fast, typically going west to east at more than 1,000 miles per hour, as shown here for the 2017 total solar eclipse. The central black dot represents the total shadow in which totality occurred, while the surrounding regions were in partial eclipse, with less of the sun blocked as you move farther from the total shadow. We'll talk more about the difference between a partial and total eclipse shortly, but first let's talk about how to watch an eclipse safely. You must never look directly at the sun, so you have two basic choices for observing a solar eclipse. First, you can use projection, which can be as simple as poking a small hole in a sheet of cardstock and holding it so sunlight comes through the hole to form a small image behind it. In fact, almost any small opening will act as a pinhole projector. Here, in the shadow of a tree, we see multiple projections of the partially eclipsed sun, each created as sunlight passes through a small gap among the leaves. You can create larger images of the sun with binoculars or a telescope set up backwards so that sunlight enters the lenses and shines out through the eyepieces. This photo shows the double image you'll get through binoculars. Be careful. Not only must you never look through the binoculars or telescope at the sun, but the projected light is so concentrated that it can be very hot. Alternatively, and more fun, you can use special eclipse glasses that allow you to safely look at the sun in the sky. Just remember that you should never look toward the sun without these glasses, with one exception. If you are lucky enough to be on the full shadow path, you can and should remove the glasses during your brief minutes of totality. This brings us to why I hope you'll try to get on a path of totality. These photos and percentages show the approximate portion of the sun that was blocked along the 2017 path at the time of greatest eclipse. The photos may make it look like there isn't much difference between a total and an almost total eclipse, But if you are among the lucky people who have seen totality, you'll know it's literally the difference between night and day. This photo montage shows the sequence over about 3 hours for a partial solar eclipse. I think you'll agree it's pretty cool, but even a 99% partial solar eclipse will still allow enough light through to keep the sky daylit and to keep it unsafe to look at the sun without eclipse glasses. In contrast, under clear skies on the path of totality, you'll get an experience you'll never forget. The partial phase will begin a little over an hour before the big moment. You won't notice much at first, but as the partial phase progresses, the light around you will begin to dim, and the temperature will begin to drop. Animals may behave strangely, with bird songs going silent, while nocturnal owls and bats awaken. As totality approaches, in the distance you may see the moon's full shadow coming towards you across the landscape. When the last rays of sunlight disappear behind the moon, you will see the spectacular diamond ring effect, which tells you it is safe to remove your eclipse glasses. With the sun's visible disk completely blocked by the moon, you'll be able to see the sun's outer atmosphere, or corona, which is otherwise far too faint to see. The coronal light will give the sky a twilight glow, but it will still become dark enough for you to see planets and bright stars. The only thing that can dampen the experience is clouds, but even then, you may be lucky enough for the eclipsed sun to peek through. This photo comes from an eclipse I saw in 1999. It was so cloudy that we saw virtually nothing of the partial phases, but just as totality began, the clouds opened up to give us this spectacular view. So if at all possible, I hope you will find a way to be on the path of totality for an upcoming eclipse, such as the ones in Chile and Argentina in 2019 and 2020, or the next one in the United States in 2024. Regardless of which eclipse you choose, the Totality app is your guide to everything you need to know. Download it free from the App Store, and then you can start planning an eclipse trip, learning about eclipses in general, find classroom activities, shop for eclipse glasses and great big kid science books, and more. I hope you find this video and the Totality app useful, and to show your support for our creation of these free products, I hope you'll consider purchasing some of our books or making a tax-deductible donation to the fantastic Storytime from Space program, in which astronauts read books and offer other science lessons from the International Space Station. You can make your donation with the link you'll find by clicking the About button in the app, and be assured that 100% of your money will go to Storytime from Space.